Hey guys, welcome to the notes for factor by grouping. So previously we learned how to factor a greatest common factor, and now we're going to learn how to factor by grouping. So this is a method we're going to use to factor the rest of our Unit 6. So we kind of learned the basics yesterday of kind of factoring out a greatest common factor, and we're going to use that same knowledge to factor by grouping. So what is the process for grouping, and when do I use this method? So it is super important that you only use this method, so only factor by grouping when we have 4 terms. Okay, you can't factor by grouping with 2 terms. You can't factor by grouping with 6 terms. You can only factor by grouping with 4 terms. So if you have 4 terms, you can factor by grouping. Okay, so this is a process that we're going to use to factor trinomials, binomials, everything pretty much, and we're going to make them into 4 terms. So we're going to use this process to factor for the next 3 lessons. So it's super, super important that you understand this lesson as well. All of this kind of builds on each other in Unit 6, so you have to know your exponent laws so that you can factor by greatest common factor. Once you know how to find a greatest common factor, we can factor by grouping. Now, why is knowing the greatest common factor important? Well, essentially, when we're factoring by grouping, we're doing a double GCF, which means we're going to be finding the GCF twice. It's not as bad as you think, I promise. Now, before you begin any problem when you're factoring, you always check to make sure the polynomial is in standard form. Okay? So, this is considered a double, I don't know why double is written so tiny. Let me rewrite that. Okay, you want to make sure that the polynomial is in standard form. Now, we learned standard form back in Unit 1 of a polynomial. So this is not the same thing as a standard form of a line, so it's not like ax plus by equals c. It's not the same thing. You want this in standard form. Now, we're going to review what standard form of a polynomial is. Now, standard form of a polynomial is listing or ordering the terms. Ordering the terms in descending order of exponents. Okay, so ordering the terms in descending order of exponents. So if I have a list of terms, putting it into standard form will be starting with the greatest exponent and then going down because you're descending, so you're getting lower. So this will be from greatest to least. Okay, so if we're descending, we're going from the greatest to the least. Okay, so let's go ahead and see if these polynomials are in standard form. So starting with the first example, x squared plus 2x cubed plus 4. Is this in standard form? The answer to this is no. Now, why is this not in standard form? Because you want to start with the largest exponent first and then go down. So really, if you wanted to put this in standard form, this would have to be at the front. Okay, so we could technically rewrite that and make that 2x cubed plus x squared plus 4. Okay, to make it into standard form. So I'll actually move that over here. Okay, the second one, 6x to the 8th minus 7x squared minus 5x plus 8. Now remember, we're paying attention to the exponents. We want them to go from greatest to least in descending order. Is this in standard polynomial form? Yes, because your exponents are going from greatest to least, so they are in standard form, or this is in standard form. Moving on to the next one. 2x squared minus 5x to the 5th plus 3x to the 7th. Is this in standard form? No. They actually went from least to greatest, right? They started with the smallest exponent and then got bigger. But that is not standard form. You want the largest in the front. So if we wanted to write this in standard form, right, the largest exponent would be the 7, so that term would come first. So that would be positive 3x to the 7th. The next term that we would have is this negative x to the 5th, or negative 5x to the 5th, negative 5x to the 5th. Now, I know it's negative because there's a negative sign in front of it, so I want to leave it there. And then I have 2x squared. Now, I know that's positive because if it was negative, they would have put a negative sign there, a minus sign. So that is going to be our standard form for this one. Okay, moving on to the next one, x plus 3x cubed minus 4x squared minus 5. Is this in standard form? No. Okay, so this is not in standard form. So I want to order this in standard form. So the first term would be the 3 because that's the largest exponent I see, so 3x cubed. The second largest exponent is the 2. So the next term would be the negative 4x squared. The next largest exponent is the 1 here, so positive x. Again, this is positive because if it was minus, they would have put a minus sign. And last, we have negative 5. Now, negative 5 has the smallest exponent because it doesn't even have a variable next to it, so technically its exponent value is 0. Okay, Move these, make sure they're lined up. And lastly, we have 4x to the fourth plus 6x squared minus 3x plus 2. Is this in standard form? This is in standard form, so this is yes, right? We go from the largest exponent to the least. So that is standard form of a polynomial. And you're like, why do I need to know this? Because if we want to factor by grouping, it has to be in standard form. Has to be. So if you want to factor by grouping, you want to make sure it's in standard form before you start. Now again, you're only allowed to factor by grouping with 4 terms. You can only factor by grouping with 4 terms, and it's considered a double GCF. So here we go. There's only 5 examples, so it's going to go by super quick. Okay, and again, there's a trick to find factors of numbers in a calculator. Now, I will show this to you in person if you are interested, but essentially we went over this in the other set of notes, and that is just that you would do y equals x squared, a number over x in your calculator for however many numbers you have. So again, I'm not going to go over that in the video, but if you are curious, oops, it's number over x. I don't know what I'm doing right now, crazy. Number over x. Okay, but if you're curious, you can come see me in person and I'll help you out with that. All right, number 1. So, how many terms do we have here? We have 4 terms, y cubed, 7y squared, 2y, and 14. We have 4 terms here. Now, you can only factor by grouping when you have 4 terms. So, we have 4 terms, we can factor by grouping, so we got that checked. Second thing, is this in standard form? Before you do anything, it has to be in standard form. And it is, right? You start with the largest exponent and you go down. So we're good with that. 4 terms in standard form, I can proceed. Okay, so this is why it's called factor by grouping. What you're going to do is you're going to group your terms. So you're going to group it and put the first 2 terms together in a single group. So I like to draw a line down the middle. And then you have your 2 sets. Now, when you draw your line down the middle to separate your terms, make sure that you bring this sign along with whatever term that is. So I need to know that that 2y is positive. So when you split them into groups, make sure the group split is right after the second term. So I have y cubed plus 7y squared. That's where the first group ends, and then the second group here begins, right? So I'm splitting it in the middle here. I have 2 groups now. That's why it's called factor by grouping. I'm grouping them. So you're going to do one group at a time. So I'm going to do the first group over here, y cubed plus 7y squared. I have 2 terms, so I have 2 division bars. Remember, we're factoring, so we're doing the same thing we did when we found a GCF. So the first thing you always do, you look for the largest number that they both have in common. So in this case, I have 1 and I have a 7, so 1 and a 7. So what's the largest number I can take out of both of those? Well, it's going to be a 1, right? I can't take out a number larger than 1. And then the next thing I have are the y's. I have y cubed and y squared. So the largest amount of y's I can take out is 2 y's. Now again, if this part doesn't make any sense to you, then we need to go back to factoring a GCF out. So this is review. Like, this part is not new. Okay, so the largest thing we have is y squared, essentially. Again, we don't have to write the 1. That's not necessary. So if you don't want to write the 1, you don't have to write the 1, right? Okay, so the largest thing I can take out of this is y squared. So that is my GCF. So that goes on the outside of what? It goes on the outside of your parentheses. So we have a parentheses here. Y cubed divided by y squared is going to give me a single y. I have 3 y's, take away 2 y's, I have a y left over. And remember, there's technically a 1 here, right? So 1 divided by 1 is going to give me a 1, but I don't have to write that 1 there. And then I have 7 divided by 1, which is going to give me positive 7. And then I have y squared divided by y squared. Well, why is this in green? I don't know what's going on. Oop. Okay, there we go. Should be blue. Okay, I have y squared divided by y squared. So I have 2 y's, and I take away 2 y's, so those cancel, so I don't have any of that left over. So that's all I have there. Once you do that with your first group, you move on to the second group. So I'm moving on to the second group here. Okay, I have 2 terms in the second group, so I'm going to continue with my factor by grouping. So this is my group 2. So in my second group here, the largest number I can take out of both of these would be 2, right? Between 2 and 14, the largest number is 2. I can't take out any y's because this one has a y, but the second term does not, so I can't take out any y's. So my GCF here is 2. But is it positive 2 or negative 2? It is positive 2, so you want to make sure you put a plus 2 there. Super important that you put the sign of that. I'm taking out a positive 2. And remember, your leftovers go on the inside of your parentheses. So your GCF goes on the outside of parentheses, leftovers on the inside. Well, 2 divided by 2 cancels and becomes 1, right? And that y is going to stay because nothing happened to it. And I don't have to write the 1 there if I don't want to. And then I have 14 divided by 2, which is going to give me positive 7. Once we're at this step, I want you to look at something, and I just want to stare at what we have so far. What do you notice? What's similar about our groups here? If you notice, The stuff inside the parentheses are the same. And that's the trick. The part in the parentheses should always match. If they don't match, you did it wrong. It's kind of like a self-check, right? If they match, then you're right. Like, you're doing this correctly if they match. Like, y plus 7, they match each other. If they don't match, you did something wrong. Now, you don't want to force them to match. It should match on its own. There should be no forcing going on, okay? Now, here's the only new step that we have to do, okay? So here's the new part. The GCFs are going to go into their own set of parentheses. So the y squared and the positive 2 are going to be put together in their own set. So we have y squared plus 2. They go into their own set of parentheses, okay? And then the matching part, you're only going to write it once. You're going to write the matching part one time next to it. So y plus 7, okay? So you're going to put the GCFs into one set of parentheses, and then you see that they're matching, so you're going to put a single matching set together. So your final answer is this expression right here, okay? You're like, what did we just do? I don't understand. Okay, well, we're factoring by grouping, so you have to have 4 terms, and it has to be in standard form, and we checked that at the beginning. Now, when we're factoring by grouping, we want to split it into 2 groups. We have 2 groups of 2. We have the left side, and we have the right side. On the left side, you just do the GCF of those 2 terms. We got y squared. We put that on the outside, and our leftovers was y plus 7. On the second side, our greatest common factor was 2. So we put the positive 2 on the outside of the parentheses, and then we had y plus 7 on left over. The next step, which is super important, you cannot stop here. This is not your final step. The last step is you take your 2 GCFs, your y squared and your positive 2, and you shove them into a set of parentheses together. And then you take your matching set, and you notice that they're matching, and you just put one of them next to it. So how would we check this to see if we did this correctly? Now, this is super cool because we've learned how to do this. So y squared plus 2, y plus 7. How could I check this? Well, remember when we're factoring, because that's what we're doing, we're factoring by grouping. Remember, factoring is the opposite of distribution. So we're dividing here. We're dividing stuff back out. We're undoing distribution. So if I wanted to check, I would distribute. Okay, I'm going to check by distributing. So let's check this. We're going to do this by double distributing. So I have my first term here. Okay, so if this was only a y squared, I would distribute the y squared, right? If this was only a positive 2, I'd distribute the 2. So we're going to do both of those. That's why it's called double distribution. Y squared times y is going to give me y cubed. Y times 7 is going to give me positive 7y squared, right? And then we have 2 times y, which gives me positive 2y. And 2 times 7 gives me positive 14. Now go ahead and look at what we started with up here. The exact same thing. So you can actually check to see if you got all of these correct. So remember, we're factoring, so we're doing the opposite of distributing. So like we're undoing the distribution. So if you wanted to check, you would redo the distribution and see if you get the same thing. Oops, I don't want to actually erase that because that's part of our check. All right, moving on to number 2. So we're going to go through these super quickly. First thing, check if it's in standard form. And notice it's not in standard form, right? Standard form means that I have the highest exponent first, so I have to rewrite this. So this would be 8x cubed, because that's the largest exponent, then 4x squared, positive 2x plus 1. Once it's in standard form, I check, do I have 4 terms? I do. I have 4 terms, so I can go and factor by grouping. So I'm going to split them down the middle. I have my 2 groups here. I have my 2 terms, and then I have my next 2 terms. I'm going to do the left 2 terms first. So my division bar, the largest number that goes into both 8 and 4 evenly is going to be 4. I can divide that out of both evenly. The most amount of x's I can divide out of both would be 2 x's. Right, I have 3 and then I have 2, so the largest I can take out is 2. So this process I'm going by quickly because we should know how to factor a GCF out at this point. So are we finished? No. Where does that 4x squared go? Remember that 4x squared goes on the outside of your parentheses. Okay, and then your leftovers go on the inside. So I do 8 divided by 4, and that's going to give me positive 2 because we're dividing. I have 3 x's and I take away 2 x's, so I have 1 single x left. Now 4 divided by 4 cancels, but what does it cancel and divide to? What's 4 divided by 4 equal? Positive 1 here. And I have 2 x's and I take away 2 x's, so that also cancels. So it's super important that we have that 1 there because we want to make sure that we understand there is a 1, it's not a 0. All right, so x squared, take away 2 x's, the only 2 x's that I have, and I have no x's left over. And then I close my group because I'm done with the first group. Now I'm going to move on to the second group. Okay, so moving on to the second group. So I have 2 terms, I have 2 division bars. Now the largest number I can take out of 2 and 1 is going to be 1. That's the largest number I can divide out of both. Now I can't divide out any x's because the 1 does not have any x's. So that means my GCF is just positive 1. So that'd be positive 1. I want to write a plus 1 there. Okay, and then I start dividing. So I start with my parentheses. 2 divided by 1 is going to give me 2. And this x is going to stay there because nothing happened to it. And then positive 1 divided by positive 1 just simplifies to positive 1. And then I close my group. Now at this point, what do you always check for before you move on? You always check to make sure your parentheses match before you move on. So looking at my 2 sets of parentheses, they match. So I'm good to go. Okay, next step is you take your 2 GCFs, your 4x squared and your positive 1, those get shoved into a set of parentheses together. 4x squared plus 1. Okay, and then you take your next set of parentheses, which are the matching ones. So 2x plus 1, 2x plus 1, those match, so I'm going to put those here. And that is my final factored form, my final answer here. Now, how do I check to see if this is correct? I can double distribute like this and see if I get the same expression that I started with. So you can always check when you're done. All right, number 3. All right, so first thing I check for is it in standard form? It is in standard form. So next step is I'm going to check I have 4 terms, so I can split it into 2 groups. Starting with the first part here, I have 2 terms, I have 2 division bars. The largest number that goes into 40 and 10 evenly is going to be 10. The largest amount of x's I can take out of both would be x squared. Well, the first one has x cubed, the second one has x squared, so the largest I can take out is x squared, which means my GCF that goes on the outside of my parentheses is 10x squared, leaving my leftovers on the inside. 40 divided by 10 is going to give me 4. Remember, we're dividing. X cubed divided by x squared. I have 3 x's, I take away 2, I have 1 left. 10 divided by 10 is going to cancel and give me positive 1. 10 divided by 10 is positive 1. X squared divided by x squared, well, I have 2 x's and I take away 2 x's. I have no x's left. So I close my group. I am done. Moving on to the second group, I have 2 terms. Now the largest number that I can go between 32 and 8 would be what? 8. Now I don't know if you noticed this, but look what happened. Your first term in the group is a negative. What happens when the first term in the group is a negative? You must take out a negative. So if the first term in the group, now we learned this when we factored by GCF the day previously, right? So if the first term in the group is negative, you must factor out a negative. Okay, so because the first term is negative, right, the first term in this group, so the 8 being negative doesn't really matter, but because the first term in the group is negative, you have to. Now I can't take out any x's because there's no x's on the 8, so the largest GCF is going to be negative 8, and then I start my parentheses and I start simplifying. Negative 32 divided by negative 8 is positive 4. Now I have an x left over because I didn't take anything out, and then negative 8 divided by negative 8 is positive 1. Before you ever move on, you always check, make sure your parentheses match each other. And they do, so we're good. You take your GCFs and you put them in a one set of parentheses, so 10x squared minus 8. And then you take your matching set and make sure that they match, and they do. And we put one of them next to it, 4x plus 1. Okay? Remember, factoring is undoing distribution, so we're undoing double distribution here, right? Because technically somebody double distributed and they got this. So we're undoing all of that and then putting it back into the parentheses. All right, moving on to number 4, okay? First thing I check for is it in standard form? Yes, you have the largest exponent first going down. And then you split it because you have 4 terms, so you can factor by grouping. You have to have 4 terms to factor by grouping. And so I will now begin my factor by grouping. Okay, so we start with the first 2 terms, start here. Okay, the largest number I can take out of both 5 and 2 would be 1. That's the largest number that goes into both of them evenly. I can't divide out a larger number than that. And then the largest amount of n's I can take out would be 2 of them, n squared. Right, the first one has 3, the second one has 2, so I can take out n squared. So my GCF is going to be n squared. Again, I don't have to write the 1 there because it's understood that it's there. 5 divided by 1 is going to be 5. Right, 5 divided by 1. N cubed divided by n squared is going to give me 1n left over. And then I have negative 2 divided by 1 is going to give me negative 2. And the n's cancel because if I have 2 n's and I take away 2 n's, I have no n's left over. Moving on to the second set. Okay, I have my second group here. Now the largest number that goes into both 30 and 12 would be 6, I believe. Is it 6? I think so. Am I crazy? Yeah, I think it is 6. Okay, the largest number I can take out is 6. Now, because the first term is negative, what does that mean? It means I have to take out a negative 6. And I can't take out any n's because a 12 doesn't have any n's. So we have negative 6 here. Oops, that should be purple. My bad. Okay, and then I start my parentheses. So we start simplifying. Negative 30 divided by negative 6 is going to give me positive 5. I have that n left over still because we didn't take out any n's. Positive 12 divided by negative 6 is going to give me, whoops, negative 2. Okay, now before you move on, always check to make sure you have matching parentheses. That's an easy check because you're like, okay, if they match, then I'm doing this correctly. If they don't match, I've done something wrong. So we have n squared and negative 6 are going to go into a set of parentheses together. The GCFs go together in a set of parentheses. And then you notice that your matching sets do match, hopefully, right? And then you would write one of them next to the set. And this would be our final expression, final factored form here. Again, factoring is the opposite of distribution, so we're just undoing all of it. Last one, 4 terms. So check. Is it in standard form? Yes. Goes from the largest exponent down to the least. Split it into 2 groups. Start it over here. The largest number I can take out of both 49 and 42 would be 7. So that's the largest number I can take out. The largest amount of n's would be n squared, 2 n's. With the next set, oops, I don't know why I'm moving on to the next set. I'm going crazy. All right, so then we're going to simplify. So 7n squared would go on the outside of our parentheses. And then we have 49 divided by 7, which would be 7. N cubed divided by n squared gives us a single n left over. Negative 42 divided by 7 is negative 6. And the n's cancel. Moving on to the second set of our groups, or our second group, I'm sorry. We have 2 terms. The largest number that goes into both 21 and 18 is going to be 3. Okay, the largest number is 3, but because that first term is negative, I have to take out a negative 3. So I put minus 3 in the front of my parentheses, and then I would start it, and then I'm going to start simplifying. So negative 21 divided by negative 3 is positive 7. I have the n left over, and 18 divided by negative 3 is negative 6. I double check to make sure my parentheses match, and they do. My GCFs are going to go into one set of parentheses. And my matching set, which is 7n squared, or 7n minus 6, goes into the other set. And that is it for factor by grouping. So it's kind of the same thing, you're just doing a double GCF. If you have any questions, please feel free.